In a previous video, I spoke about one possible way of implementing the approval system, and we will talk about why this is a poor approach. Let's assume that the logic I placed inside this for loop to check to see if the person sending the transaction is inside the approvers array, and we flip the Boolean to true, and it costs 10,000 gas for every person who has donated to the campaign. And in a similar fashion, the require statement costs 5,000 gas to execute. Now, it's a total of 15,000 gas, right? So doing some math as to how our gas cost is going to scale. So just for one person to check to see if they're a member of the campaign, it costs 10,000 gas, and then an additional 5,000 gas for checking to see if they have already voted. So it costs a total of 15,000 gas. So gas is the cost of executing code inside the contract. So this is not an actual calculated cost, it's just a hypothetical, but it does cost gas. So now we need to develop a voting system for many thousands of contributors inside a single campaign. So what happens to our gas costs when we imagine a campaign with thousands of people? Imagine we have 5,000 contributors. We have run the for loop 5,000 times. So we've run that for loop 5,000 times for each contributor, times 10,000 gas, right? So that's already, we got there, I don't know, but let's add to that to check to see if the contributor has voted before, which costs another 5,000 gas times 10,000 contributors. Well, all that will equal to about 150 million in gas, or I'm sorry, 150 million gas. Let me make sure I'm saying 150 million gas. That is the currency that we're using to execute code. It's not gasoline if you just walked into this video. So as we get more contributors to this campaign, we're incrementing the cost of our approved request function by 15,000 gas every time we're spending and every time we're spending a real tremendous amount of money for this process. So this is why this is a poor approach. That's why using an array for addresses, and do I have that? Let me see if I have that. No, I don't have it. Oh, well, but this is why using the array, or the outside array, and then, so for our addresses, and then an array for addresses inside of a given request, it's a poor approach. So this is a case where we're designing a contract where we're designing an array that grows unboundedly. So we have written our contract in such a way where we assume that the array grows without bound and have no way of restricting the bounds of the array. And we probably don't want to restrict it anyway. We want to allow as many people to donate to our campaign as possible. So this problem is related to any type of use of array data structures in a contract. If you're storing data inside an array, and then you have some logic that eventually loops over that data, loops over that array, you have to be 100% sure that your contract will never end up with that array growing tremendously. If it does, you're going to be paying a tremendous amount of money in gas. So this implementation is way too expensive because we have these array data structures that we have to loop through to see if they're a contributor and if they voted before, and because we're looping through that contract, we have to spend a tremendous amount of money as more people are introduced. So I encourage you to avoid working with arrays wherever possible when developing your own contracts. So I'm going to be using a different data structure so I don't have to iterate through every record inside there to see if someone has contributed already or if someone has approved a given request already. In the end, it costs way too much gas, and it might cause the contract to not even function anymore at some point. All right, so in the subsequent video, I'm going to talk about how I can address this with some other data structure that I can possibly use to ensure that I'm still able to handle many people inside my contract and also implement the requirement of only allowing one vote per person for a given request. So stay tuned for that.